Okay. This little mini weekend session is for mostly people that want a quick review on the 5 models and maybe a little bit of a note as to breakdown of the exam that's going to be coming on Monday and Tuesday. Okay? All right. So the 5 models, what that consists of is longhand notation, shorthand, orbital, Bohr, and Lewis. Now, what each of these do is they show basically how electrons are arranged within an atom. It shows different energies. It shows where you might find them on specific orbitals and specific energy levels. So they all can be tied back to, I think, the most important of the models, which is longhand. Now, longhand configuration, or just sometimes called the electron configuration as the standard notation, really looks at this image here. Okay, so this is showing you the SP, D, and F blocks for the periodic table. You'll notice that the symbols are not located on the actual periodic table, and they're all blank. So what we can do, what this allows us to do, is to figure out the notations without having too much to hop back and forth on within like a regular periodic table. Okay, so for example, let's say that we have isolated, let's start with an easy one. Let's say we're looking at oxygen. Okay, so oxygen is located right here. All right. Now, if we look at oxygen, and if the question was, what is the longhand notation, what you would do is, first thing you want to look at is see where it's finished. Where is its last notation going to be? It's in the 2p group, and it's 1, 2, 3, 4. So it is the 4th element in the 2p group, or 2p block. So I know it's going to finish at 2p4. Okay, I want to then write everything that precedes it and just write it out. You always start in hydrogen's position, so that's 1s. Helium is also 1s. The next spot down is 2s. And then if we're reading this like a book, which is how you do it, we then are in the 2p group, which is where we kind of had our final notation. Everything that precedes the 2p group is full, kind of like that POGIL activity allowed you to visualize the rooms have to be full before you advance to the next block or the next room. So the S block can hold a maximum of 2 electrons, so we're putting in the exponent 2 in there. Okay, so we have 1s2, 2s2, 2p4. This is the longhand notation for oxygen, okay? Now, if the question was, well, what's the shorthand notation? What you do is you look at where oxygen is, which is right there where I put that purple dot, and you trace backwards until you hit the prior noble gas. Okay, the noble gas is in that spot that I circled right there. That's neon. If you're looking at your periodic table, you would notice that that is neon. Okay? Neon is your starting point, and then essentially you're just taking that last row of notations until you hit oxygen. So really we're just looking at 2s2 and 2p4. So that becomes, sorry, you have to put the noble gas in brackets. That becomes my notation. 2s2, 2p4. Okay? All right, so then the next thing that we can do is we can look at the orbitals. The orbitals are the arrows. So these are the structures for your orbitals. Now on the exam, you're not going to be provided this template. You have to be able to write it out on your own. The easiest way to do it is to just take the notation that you did for longhand and write those blocks vertical. So you'd go like 1, 1s, 2s, 2p. Okay, now the S subblock can hold 2 electrons, so it gets essentially one horizontal line here. One horizontal line for the 2s, and then the 2p gets 3, basically. Okay, now how many arrows you put in each of those blank lines is determined by the exponent that you have right here, here, and there. So in the 1s, I get 2 arrows, 1, 2. In the 2s, I get 2 arrows, right there. And then in the 2p, I get 4 arrows, 1, 2, 3, 4. Okay, so that's your orbital. So this is orbital. All right, so we did those 3 thus far. The Bohr structure is your circle with your dots, so I'll do that down here. We're looking at oxygen, so there's our nucleus. Actually going to move this over. Now, the way you determine how many shells that you're dealing with for your Bohr structure is you look at the highest principal energy level number, which is going to be, in this case, 2. So that means I have 2 shells. So I go 1, I go 2. All right, now, the longhand notation really helps you out with this. So I'm going to actually just duplicate this and bring it down, if it'll let me. The first shell gets 2 electrons, so 1, 2. The second shell gets 2 plus 4, which is 6, 2, 3, 4, 5, 6. Okay, so there you have it. That's the Bohr structure. Now the last model that you have to show is the Lewis dot. That, I think, is the easiest one. What you do is you take the symbol, which is oxygen, and you're just looking at valence electrons, which is the electrons in that outer shell. So that's all we care about for Lewis dot. How many dots do we have in that outer shell? Which for oxygen's case is 6. Each dot gets its own side before I go back and I double up. It doesn't matter which side you double up. You could very easily have this conformation where it looks like this. It's fine. The dots just have to be kind of right next to one another. Okay? All right, that's all 5 models. Now, if you want a more complex one that deals with the transition metals or with ions, look at the prior video that I posted on Thursday, Friday's folder. Or I guess I should say Wednesday, Friday's folder. Okay? All right. Here's what's on the exam. Here's our exam breakdown. Okay, now you're not going to be able to use your periodic table. We'll say that first. You're going to use one that's not labeled, just basically one that has, before you made all your marks on it, all the coloring, all the labeling, all the ion charges. Okay, you'll get a calculator that will be provided by us, and obviously a pencil. But first thing you want to look at is the energy and waves section. Look over the notes, look over the documents that we worked on in class and that you had for homework. Things that are important to remember and understand are frequency, wavelength, and energy, which is kind of what I'm just reading through it right here. What are the relationships, and can you do calculations from it? Roy G. Biv, what does that mean with relation to frequency and energy? Look over your flame test. Be able to explain why certain colors are produced versus other colors. Think about the stair-step model that we did. where I was jumping up on the different steps and jumping down, and why it was violet versus red versus blue versus orange. That's a good thing to understand and be able to recount. Okay. There's going to be an atomic structure table, so protons, neutrons, electrons. There's going to be ions involved, so think about how ions interplay with that breakdown of protons, electrons, and neutrons. You got to know some specific characteristics on metals versus nonmetals. Go back to the notes and look for that one slide that we covered on metals versus nonmetals. There's only really one question on that, so don't spend your whole night studying it, but definitely go back to the notes and look it over. Trends are obviously big. The three you're going to be responsible for is radius, electronegativity, and ionization energy. Okay, also how do ions play into each of those? So you'll want to look at the video that was posted on Friday that discusses ions and radius. You can kind of use that understanding to extrapolate it out to electronegativity and ionization energy as well. All right, and then obviously your 5 models, longhand, shorthand, Bohr, orbital Lewis, what we just showed. And then there's our ever favorite ACT passage to finish. Thing that I will say is the notes are really helpful. The review sheets, the 2 review sheets that you guys were given, the keys for those are posted. Those are really good. It's a really good indicator for the exam. The gizmo is nice to look at specifically for ions and how that plays into it. So yeah, make sure to check those over. I'm going to post a review game in the Schoology in like a moment here, so look for that as well. That's a good thing to practice, but I would say looking over the reviews is more helpful. Okay, good luck studying. Email me if you have any questions.